Okay, so on Albert 4.1's assignment, the first question is asking us to calculate a residual. So the way we calculate residual is you're going to take the observed measure. And in this case, we're observing that the baby weighs 8 pounds. So that's your first number that you're going to write down. And then to calculate the residual, you subtract off what you expected or predict to happen. So to figure that out, you got to plug in the 28-year-old mother, plug it in for X, solve for your prediction, and then you're going to do 8 minus that number. And it is as simple as that. So let's take a look at the next problem. I feel like on these types of problems, we've talked about these quite a bit, where you're given computer output and then you're asked to write a least squares regression line equation. Remember, this first number here is your y-intercept, and the number right below it is always your slope. So with that said, hopefully that'll help you write your equation in the format of y equals a plus bx. All right, here's another review question. I'm asking, or the program is asking us to interpret the slope. And remember, the key term is your x-axis has to increase in single increments. And pay close attention to your slope here. It is, in fact, a negative number. So on average, or the estimation, you have to use some kind of verbiage or indication that you understand that the slope is on average doing something, or expected or estimated to do something. I don't necessarily completely agree with the terminology on Albert here, just because the AP readers want us to use the word average. So if you don't see average explicitly stated on your choice options here, that's okay. But you do want to make sure you understand that this is in fact an estimation, and it looks like to me the slope is going down. So keep all of that in mind. We love some normal distribution problems because we can either use normal CDF or inverse norm here. In this case, they're giving us the probability, they're giving us the actual answer. So make sure you use inverse norm on this particular problem. It is the lower tail, so the probability is 0.1515, and you know that your mean is 0, and you know that your standard deviation is 1 because we're dealing with z-scores. So that's all I'm giving you on that one. Let's take a look at question number 5. On this problem, again, we're given the percentage. Make sure you convert that percentage to 0.05 though. This one's tricky though. It's still inverse norm because I'm given the probability, I'm given the percentage. I know that's 0.05. But it's talking about above, so the above is 5%. And remember, when we're dealing with percentiles with our inverse norm calculator, it's read to the left, and this is a number to the right. So if you have to draw a picture, do that. My hint here is two numbers, or two things, inverse norm, and you don't want to use 5%. You actually want to use 95%. Make sure you understand that. So you'll use 0.95 as your area. This is hopefully a gimme problem, approximately normal. We know the mean, we know the standard deviation. It asks us for the probability, so this is normal CDF. It gives us the lower bound, it gives us the upper bound, so make sure you use all of those numbers wisely. Here you're given a box plot. You're asked to calculate the IQR. Remember, the IQR is the length of the box, and you actually have to subtract those numbers. Don't show the numbers, just subtract them. IQR is one single number. Great question about beads here. When doing sampling, remember the one thing that is the absolute most important thing that we must ensure is that randomization is taking place. So randomization is key. That's all I'm giving you on that one. Here we want to take a random sample of 100 students. Going to the cafeteria. Maybe not everybody goes to the cafeteria during lunch, so that would be under coverage. 100 students are enrolled in AP Stats, sample those 100. Again, not everybody takes AP Stats, so that's an example of under coverage. Obtain a list of all the students, assign them each to a number, use a random number generator. That one looks pretty good. This is on the lines of an SRS. Let's go on to D. Since government is a required daily course, survey all the students in the government classes during one school day. Okay, everybody has to take it, but what about the kids who are homesick or absent? They have not been included. And then let's take a look at E. This is convenience. If they're your friends, that's because it's convenient to you. So that's a convenience sample. So I think that one is a pretty obvious solution. Remember, on a problem like this, if you're asked to stratify, let's see here. Suppose a worker wants to know how they feel about healthy foods. What would be a useful, to stratify. So that means you want to group people or group individuals because they're the same. And we're interested in knowing how people feel. So stratifying by food makes no sense. Grouping people by ID number does not make them the same. Gender makes them the same. Homeroom teacher kind of makes them the same, but gender more so. And number of siblings has nothing to do with the question here. So I'm thinking it's probably gender. And that's it, folks. I helped you with Albert 4.1. Hopefully you are happy with your score when you take this complete this assignment. You guys have a good one. Take care, and I shall calculate later.